paper for further research kind of ideas. But we should be able to get some kind of visual. It is important. And the reason it's important is you are occasionally going to get really weird readings from streams that can be very easily explained if you just see what's going on. But if you can't take a look at it, and you're just watching this data scroll down the screen, and you're like, oh, okay, why is it doing that? You now have to drive 30 minutes out there, figure out what's going on, fix it, drive all the way back. I mean, it's kind of defeats the purpose of having this remote monitoring system if you're having to go out there every time something looks a little weird. But if you can just look and see, oh, hey, tank 3 is low and the water level sensor isn't working, or okay, we got some eutrophication in there and that explains it, I need to go clean that out, or why are all the fish dead? That's bizarre, I should go look at that. So I mean, it's just, that helps a lot. And Dr. Hoinghouse has another idea that he kind of wants to implement to bring this to classrooms. So if we've got this video stream going through a website, the cameras that we're looking at actually allow you to control them to a certain degree with pan and tilt. You can give that access to students, and you can have a website where the data we're collecting is streaming, and there's a video camera going, oh, I'm sorry, it's Dr. Thompson's idea? There we go. I heard from Dr. Hoinghouse and made an assumption, and you know what they say about assuming. Moving right along, it lets the kids see the data that they're actually collecting and using, and they can look at the thing, and maybe eventually we'll figure out a way to put a scale on it so they can kind of see how big the fish are. Maybe have a little guide that lets them identify, oh, that's a this and that's a that, and then maybe whatever you've got in there. Just so the kids can kind of get involved and hands-on and see actual research that grad students are in the process of doing. Makes it a little more real, makes it a little more interesting, I think, and I'm pretty sure that's the general philosophy.
That says questions. You haven't been reading, but
All right,
I have one on bacteria graph.
Yeah.
10 EO pH. Line for 10 shows some spikes. Shouldn't be there, right?
Correct.
So what's going on?
That is a wonderful question. With some of the thermistors that we're using, we have noticed they are obnoxiously sensitive, and they tend to overreact. Like as soon as it starts to get warm, they'll jump 2 degrees and then come back in line with what they're supposed to be. And I have no idea why they're doing that. Yishin, do you have any idea why they're doing that?
No.
Yes, sir? Do you know why we're getting these big spikes, or is it just weird data? I will say this, we have a lot of data packets that are dropping out randomly, and so some of the minimums that you're seeing are not real readings, it's just been zeroed for a second, and it's thrown off the graph. Because once they zero, it takes them a second to come back in line. We're taking readings every 8 seconds, and these things seem to be taking 10 to 15 seconds to normalize. So if one drops to 0, we're getting some funky readings after that. That might explain the ups, I don't actually know.
They could be filtered out by program, right? The program could implement some sort of filter that will
If you see,
the last so many readings.
yeah, there's got to be a way to smooth the curve. If there's a big spike or a drop, you can take that one out because it's anomalous data. It's got to be possible. I'm not sure how to do that.
Actually, this spike is typical phenomenon for the Arduino because they have their SD converter is not that stable, so sometimes you get variation. Usually, you can take a very simple filter design. Basically, if you have samples that have t equal to 0, t equal to 1, t equal to 2, t equal to 3, what you can do is you just take the average of the current one with previous 2. Add them together and divide it by 3. And then that's a very simple low pass filter.
So this isn't a pro problem, it's a software host?
No, that's what you get is the data reading from hardware. But the data you can use is you some post-processing. Okay. Instead of showing the raw data, the post-processing is just basically average of the current one with previous 2. Then you do the moving average for all the following. Then you can reduce the
So I'll get rid of some of the noise. And get us the normalized.
There, we stumbled across the example code for and they helped us find it, there's a smoothing code that actually does like this through rolling average.
Okay, so there's already a library, we can just pull that code.
Yes.
That's great news, thank you for that.
My answer is, all these data are original, real data. So I don't like to change anything about it. So maybe it's because the purity of the produce. I mean, the produce procedure of the sensors. I think we can do something in data tree, but actually the curve can express the real situation of the water body.
But that conflicts what Dr. Fu was just saying, that it's an artifact of the electronics, not a real value of the water body, right? So which one's which? You seem to be contradicting each other, I just don't understand.
I think it's a philosophical difference at this point. Dr. Fu is saying this is a known error and it can be corrected. And Yashing is saying, if that's the data, that's the data. So we've got a purist versus somebody who's trying to real world.
Well, I mean, that's the data, if you want it to be useful for control, for example, you do want to filter it, because you want a control system to be responding to those spikes, whether you believe that's data or not. I mean, how could temperature change?
It's unrealistic that the temperature would come to 2 degrees in 8 seconds. Not like,
That's not feasible. That's just not feasible.
we'd be flash boiling some fish.
What made you pick 8 seconds as your interval?
That's how long you're supposed to stay on a bowl. Next question.
What did you say?
For bull riders, you're supposed to stay on for 8 seconds.
Oh, okay.
So.
That's an arbitrary number.
What's the cycle of your thermistor?
Sorry?
What's the cycle of your thermistor?
That's actually why. That's just less funny.
Is it 8 seconds?
So we could go more than 8, we couldn't go less, because that's how long it takes to actually cycle the rows
Right, but if it takes about 10 to 15 seconds.
to normalize.
Normalize. Why did you go with 16 seconds? Right.
Exactly.
I do feel like we should link that. The problem is we were only doing a 24-hour run, we wanted a bunch of data points. So the original idea was 30 seconds, and then we dropped it to get enough data points to make sure we weren't losing packets. Which, but apparently that's not that's also.
Let me explain here. Since we have 24 hours to capture all the data we need, for 8 seconds every capture, we will get 15,000 data for 24 hours. I mean, if we split the temperature deal and the pH, we will get 3 times higher data. I mean, 150,000 data to process. This load is too heavy for computer. Since our curve is generated by Internet Explorer, too much data will make the computer down.
Yeah, and I agree. I mean, I don't think separating it, but I think 16 seconds then might actually take out some of those peaks without having a filter. Because if it is just zeroing out and then spiking after the zero.
That's right, and you could, even if you collect your raw data at 8 seconds, you may record it back to the computer on the web at a longer interval, where what you're reporting says over 16 seconds. Well, you have 2 readings that go into that report of the other reading. See what I mean?
That's a good idea.
So for anybody who wants to take a look at the actual sensor cluster that we have, we've been carrying these around and dropping them on the floor and stuff for a while. So you might have seen us walking around with one. But we will leave this up here for anybody who wants to come take a look. And then we'll come back and get it later. Any other questions or, oh, I missed one.
No, yeah, I just thought about it. So you guys said you moved to a smaller box than your nodes last year, right?
Yes.
So how are you dealing with that heat issue, or are you not having a heat issue? 'Cause I thought you said the Arduino was producing some.
We didn't have a real heat issue last year. This year, that is becoming a bit of an issue, because when we popped the cases yesterday, after running for 24 hours, it wasn't, oh my god, we're melting the board hot, but it was noticeably warmer than outside, and right at the power junction and just under the microprocessor, it was warm. The processor was slightly warm to the touch. The power junction was blazing hot, and when I touched it, so that could eventually be a problem if we're gonna run it for days at a time. So I like the idea of the OtterBoxes because they're waterproof, but we're gonna have to find some happy medium between waterproof and a cooling system, because that could end up being a problem. Yeah, but it's 1,000,000 degrees outside to start with, and now you've got a processor heating up on top of it. So on the plus side, we didn't know what the black box is, but that's really the only good news on that. Any other questions?
Do you use multiple set of sensors? Like, have you tried a multiple set of sensors? You just have one set, or you plan?
We have 5.
You have five. So have you tried? Are they reading the same? For
Yes.
example, for pH, like both of them, all of them have those spikes, or?
They do,
They
they're not
may be-
necessarily in the same place, so it's random when we're getting spikes for each device.
Okay.
But they are all
So,
displaying them, just
Yeah,
not in the
they
same
may
place.
self-correct them, right?
Right.
If you compare the readings from.
And this, bear in mind, is the reading from a single
From
node.
one,
This is
right.
from node 11.
Okay.
We have a separate graph that kept crashing the website when we were trying to produce it, that has all 5 of them averaged together, and it's a lot smoother, but you do still see some noise.
Going back to, so each one of this is producing